Right. Hello, everybody. Welcome back to Electric Vision Entertainment, where we are all about tech, thoughts, and thick hair. Although I guess I'll call this my thick hair today. Um, Welcome back again. If you've been here before, you already know what we're about. We're about coding, we're about robotics, hardware, software, and sometimes we just have thought explosions, as I call them. Times where we just focus on concepts. Maybe we'll do one of those type episodes coming up where rather than focusing purely on code or purely on hardware, we'll focus a bit more on the ideology of things, more about the historical backing of some of the electronics or some of the evolutions that are happening in terms of the robotic software technologies that are evolving right now. Who knows? We might try other shows. Like I said, it's an evolving show. As you've been here over time, seeing it evolve, definitely feel free to give us feedback about what you want to see on the show, as well as improvements you think that we can make, just to make it more welcoming to you all, more interactive, build that community up, or just simply say you want to learn how to build a robot, not a robot. We're always going to be building robots. Say you want to learn how to build a drone, then you can bring that up. Say, hey, let's learn how to make flying ones. Cool. So maybe that's something we can put into the repertoire as we go forward. Or you just want to learn how to do, as I mentioned before, surface mount soldering. I'm no professional. I'm barely a noob at solder melt, surface mount, but we can definitely learn together because it's definitely a very useful skill in electronics. So let me know if it's not or if this is your first time here, then welcome. We are going to be building cool stuff on the show all the time, every week at the same time. So make sure that you subscribe and join us on Discord at make.sc/join Discord. And then just come back here every Saturday. I'll keep reminding you. As well as we'll be working, like I said, on different electronic stuff, hardware things, and just simply chit chatting, hanging out, enjoying a nice Saturday, doing cool tech stuff. So, that being said, don't the title on here. Today, before we go into today, for the past 2 weeks, we've been working on making our own Arduino. There's ones that are already made. Of course, the original Arduino by the company Arduino. The microcontroller itself is not called Arduino. That's just the company that makes it. But they're just the biggest one out there, the most kind of reliable as we go by. But it's just a microcontroller like this. This is the off-brand one. I don't want to say off-brand, but it is. And it's the same concept. It has the same more or less pin map, because the pin map, when it comes to how things are laid out, really just is related to the circuit rather than the actual board itself. The board just makes things happen. So that's what we're doing on the show. We're making our own board, and we've been working on it for 2 weeks. Hopefully, we'll be done next week. Looking at how we're going, I don't know if we'll finish it all the way this week. We're gonna try, and so we got most of our parts on. But then we got the pin map. I'll go ahead and pull up the pin map so you can see what that looks like. And 1 second, and I'll pull that up for everyone. This is our pin map for the circuit that we're building. The chip is an Atmega 328P, and so that's the actual brain of everything. If this circuit was a person, then the current is like your nervous system. The power is I guess like your cardiovascular, so it's keeping you alive. I don't know. The integrated circuit is like the brain of it all. So even despite everything else in the body, we got to make sure that brain is properly connected to everything to control everything else. So this is our pin map for it. We already have it laid out on our circuit. What the goal is today for trying to get this up and running. I know last time we were delayed because I didn't have certain capacitors, which I still don't have, partially. There's a certain two that I'm using that I'm pretty sure should work. The only thing that's concerning with my circuit right now is some of these capacitors, but it should be fine. Should be. Not they're gonna they might overheat, in which case I'm just going to unplug it. So I have 2 of them that are necessary for our crystal, which is going to be, if you look at our pin map, it's going to be around 9 and 10. So not the numbers in blue, but the numbers in black closer to it. 9 and 10 is where our crystal is. Actually, it says crystal. So we needed resistors for those, or capacitors for those. I have those. Pretty sure they're correct. Pretty sure. And the other ones we were missing, I technically have the right amount. Like, it's a 10 microfarad capacitor. However, when I was looking at the build for this, it required, or it asked for a specific type. Don't remember off the top of my head what the name of it was. But it asked for a very specific type of capacitor. There's several different ones. I think I showed you 2 before that. I'm actually going to switch to my desk so I can point them out for you. And I'm going to zoom in. So if you look now, this is where we are. This is where we're at. Forgot to change the lighting on this. I can do that in a moment if need be. But you see up here, at the very top, we have these capacitors. You can see a little closer on the zoomed in part of the screen. And then down here where we have our crystal, let me scoot it up because they're super tiny. You can see over here, these 2 are also capacitors. And these are just basic ceramic capacitors. But the ones that they wanted us to use were going to be down here. Going to be down here for this. And this is for a 3.3 volt regulator. So that if we wanted to use 3.3 volts of power, then we can use this and plug it here. Versus 5 volts, in which case it'll go to the one up top. And then just straight power if we plug it up straight to power. Which in our case, we're probably going to use this 9 volts. I am going to rip it. So I'm going to show how to do that on the stream too. Today's going to be kind of a hodgepodge of different things. Just because, for one, it'll also might be a little debugging heavy. As long as nothing breaks. Because in theory, according to the schematics, according to the pinout, etc., then this should work. If we ignore the 3.3 volt section, we're going to. Because I personally have never used 3.3 volts, and I probably won't. So when it comes time to plug this up to power, I will probably take off this regulator so I don't blow it. But we're not going to use this. So I'm just not going to worry about getting those other capacitors and setting that section up. So we're going to do, I'm not going to jump into it yet. Like I have some other announcements. I think I do. We are going to solder today, so I do have my glasses. So we're going to do a little bit of that. Speaking of, let me turn it on because it's going to take a while to get heated up. So that's number 1. Make sure you have your goggles, as I have, and open a window or have a fan so you don't inhale all the smoke. And then also, I'm going to bring this up before we get started. I will probably put out some form of poll about this just to see. I'm not sure if I'm going to do it on Discord, if I'm going to do it on my Instagram, or what. Probably both, just to get more feedback. But as I mentioned before on the last show, I invested in getting a robot for us to build. And it is, this one is heavy. I'm trying to pull it out. Ugh, it's huge. This guy. This hexapod, 6-legged. Let me pull up my other one so you all can see me. So it's gonna be this one. I know it's kind of reflectory, but it's a giant 6-legged robot, and it has a lot of features like optical avoidance, video recording, alarms, the ability to carry and transport objects, things like that. I will probably start building it soon because the hardware part, as much fun as I enjoy doing it, I know sitting and watching me just put screws and things not only will take forever on a live stream, but also it's as interesting, and it's not really something to learn so much as something just to do, like follow the instructions, try to build. So I'll probably do that off camera. and I'll take clips of it. And whenever we decide to do that robot, I'll play the clips of me building it first, and then we'll go into the hardware or the software. That is really the more important part. And the reason being is because it's built using the Raspberry Pi. Raspberry Pi. I actually was going to switch up and do an episode about this today. And then I realized in the last minute bit of panic that Raspberry Pis and Arduinos are not the same. Well, I knew they weren't the same, but in terms of the Arduino is a microcontroller, right? All that matters is really the integrated circuit, that piece that we have that we just talked about, and using the rest of the board to make it expandable. So you can like plug in different things to it and control the robot. However, a Raspberry Pi is not simply used for pin outs and pin ins, even though it has it here along the side. There's some little headers there, and they kind of align to the same input pins as on our Arduino. But this is a whole computer, not a just piece of microcontroller software to use to build other hardware. This is a whole literal computer. You can put operating systems on it. You can run servers off of it. I definitely encourage you to look up on whichever platform you use Raspberry Pi builds, because people make some really crazy, like top of the line computers. I know people at one point were getting like tons of these to build servers to do like Bitcoin mining off of, which I vaguely considered. And who knows, maybe I think this is my second Raspberry Pi, so maybe I'll get a third one and we can do like a little episode where I learn how to set up the server for this and do like Bitcoin stuff. But like I was going to do this today. And then I realized because it's its own computer, I have to have an external monitor, an external keyboard, mouse, some other devices to hook it up. And then I have to get the SD card and flash it and then put the operating system. It was a lot. And so I realized, like, we're not going to do this today. So depending, that could be an option. So I'm just throwing options out here, you guys. I'll throw them out later again, so that if you're interested, you can let me know what you are wanting to look at. If you want to learn about the Raspberry Pi independently, we'll probably do that anyway, because the next 2 robots we're going to do involve that. Speaking of, this is the other one. I built him a while ago. If you follow me on Instagram, you'll recognize this robot. I built him like 6 months ago or something. It's my baby. It's a smart car. And it's also built with a Raspberry Pi. Don't really want to try to take the hat off because it's screwed on there. But down here in the second layer is the Raspberry Pi. And then up top is just a hat for controlling other circuitry. There's a lot of different... My camera's not going to pick it up. There's a lot of different circuitry going on to this robot. So the upside to this one is already built, so it'd be a lot easier to jump into it. I do still have to do a lot of the flashing for the Raspberry Pi to get it set up, but we can also work on this. So we got a couple options. Like I said, put in the chat, reach out to me online, Discord, whichever. Let me know kind of what you're thinking about. Drop a poll out there. Like, what do you want to see me do? Do we want to go ahead and jump into the one that's already built and focus on programming it? Do we want to get into like the really big other cool robot? Either way, I'm going to build them out both. Well, this was already built out. We'll build the other one out hardware-wise, and then we'll go from there. So those are quick updates. Let me get back to, if no one has any questions, comments, etc., then I will go ahead and move forward with the show. Give chat like 2 seconds. Okay, so I'm gonna go back to showing this. All right, actually I'll pull up the Zoom as well. So I said we should already have everything laid out. I'm gonna go ahead first and take off this 3.3 because I want to test it. Well, yeah, we're gonna do 3 steps here. I'm gonna say it out loud because I'm gonna forget them. So So the first thing, I'm going to take this 3.3 volt off because I am going to connect this to power. I'm not going to connect the power yet. There's one other step I need to do beforehand in order to test if this is going to work. Yes. So what I'm going to do, like I said, I'm going to take this off because I don't want to blow it just in case. Since there's no capacitors there to hold extra current, I don't want to accidentally overload this and burn it out because it might happen. And I'm concerned that some other things might get blown out, but we're going to find out, won't we? So the next step that I'm going to do is not to unplug my mouse. I'm going to invest in a one of those USB adapters and turn one USB into like 8. I'm sitting here and I'm like unplugging things so I could plug in other things. It's a lot of cables on my desk. So what I'm gonna do is, I mentioned before, because we have this on a breadboard, we can't program it right now. There's a way, and I would need an external module that I'm not about to build. There's an external module so that I can plug in this cable for programming. All right, just your basic cable like this. But I don't have that on here. And when we have other boards like this one, it's already built in on the side. Let's see. So the way we're gonna get around this, rather than delaying and trying to get that module again and get everything reconnected, is the only reason we need it plugged in is to program this integrated circuit. And so what I'm gonna do to get around it is I'm just gonna take this off, plug it onto this one, which is where I took it off from in the first place, plug it back into this, plug this board into my computer, program on just a basic LED. And I have over here in the corner this red one. It's just a basic LED, like power to LED to resistor to ground type thing. And I'll connect it to a pin. And we'll use that to test if this circuit works. So if I program, say, on this chip to turn the light on for 1 second, turn it off, turn it back on for another second, I should be able to then take it off of this board, put it back on here, and as long as I connect the right LED to the right pin, it should still work. As I mentioned before, when it comes to integrated circuits like this, when you're doing embedded programming, and that's part of the benefit of embedded programming, is the program sticks onto the chip rather than you unplug it and it's lost, you disconnect it, put it on something else that's lost. As long as it's on here, then it should stay, in theory. So that's what we're going to try. We're going to see if this works. It's going to be a 2-part test. One in part to see if this circuit works. I'm going to plug it in. I'm going to program it here. I'm going to connect the LED to it, to the board, while it's being programmed, just to make sure the LED circuit itself works. So that way we're getting rid of one part of debugging. This is all part of the debugging process. You want to cut out as many potential errors as you can while you go. Because say I plug it in, I program the circuit on this board, move it back here, connect everything up, and this doesn't work, then I don't know if it's because I programmed the circuit wrong, if the whole circuit itself isn't set up properly, or if I just don't have this LED laid out. So we're going to try to debug as we go to see what happens. So that being said, I'm going to go ahead and take this out and reinsert it. Make sure I remember where everything goes. I can get it out. All right. Now I just have to remember exactly where the pins go, which shouldn't be bad. I have the pin map as well as just knowing there's a one up here, this little jumper. And I know it's set to pin 1. So wherever this one is pin 1. And then make sure I put this on the proper way. Like I said before, we have this notch at the top. You can kind of see it there a little bit in the zoom. And it's going to align with the same notch on the top of this header. You can vaguely see it like right here at the edge. it's kind of outlined around the bottom as well. As you can see, it's dented on the white. So I'm gonna plug that back in there in that orientation. I feel like my pins are getting bent, but it should be fine. I'm gonna plug this back in real quick. Cool. Boom. All right. So I'm gonna plug this in. Okay, so I'm gonna show you my Arduino screen so you can see exactly what I'm programming. Hopefully it's not too blurry because I know it was being a little funky earlier. So this is just the basic circuit like I mentioned before. We're just going to turn it off, turn it back on. Let me pull this up. All right. So we have here is going to be set to pin 13. So on my first off, before I even do that, I'm going to go ahead and send this to the board just to make sure. So you go up top to your tools. Hopefully you can see this. If not, I think I'll just say it out loud, but you go to your tools, you make sure you select the right port. Usually it'll only give you certain ones, and then make sure you pick the right board, which in this case would be an Arduino Uno. And then we are going to verify it, make sure it loads. I know the loading bar at the bottom is a little cut off, but trust me in the fact that I say it is currently uploading. Okay, cool. So what we're going to do is then set this up to 13, which is an output pin. And then it's going to come down here, turn it high, delay for 1 second, 1,000 milliseconds, turn it off, that. So going back to the desk share, so you can see that. And this is where we are. I'm actually going to do it this way. Boom. No, it's a little bright. So what we're gonna do is I'm gonna go ahead and connect the rest of this circuit up, and just we're gonna do just like we did all the other times we did LED circuits. I'm going to get a blue wire or black, but blue is what I grab first. I'll do a black wire. So got a black wire. I'm gonna connect it to ground for this pin. Because the only reason I'm doing it directly to, let me put it here. The reason I'm doing ground directly here, and actually I'm gonna scoot this resistor up, and I'll explain why in just a second. Actually, I can explain why now. So if I plug this ground into the blue line on this breadboard, then it will ground everything on this board, which isn't bad because we don't have power still going through it at the moment. However, just to be safe, I don't want to, since I'm just testing that this circuit works only with this LED, I don't want it to interfere with anything else. Just in case. Better safe than sorry. So let me move these out the way. I can rotate. Alright. It's a little hard to see, but we have our LED here, the resistor going from the LED over to this black line, and this black line is going to be plugged into ground on our controller. And then same thing with power. So I'm going to plug it into 5 volts, which is why, like I said again, I'm just going to skip the whole 3.3 volts because I'm never going to use it. And then I'll plug it into here. So, interesting experiment. So for one, let me pull up something real quick on my side. It is programmed, so I'm going to go ahead and say that is a yes. So that's successful. Now, where we're not successful, was what I feared, and I can't really illustrate it. I don't think you were able to see it, but what happened here is I just burnt out this LED. And I'm gonna pull up. Let me see if I can pull up a quick example of a circuit to show why I just did this. Yeah, I don't have a circuit to show you with this, but what happened was, I don't think it was very visible to see, but if you look very quickly for like half a millisecond, like a quick millisecond, you would have saw this LED turn on, and then you would have saw it immediately turn off. And you can't really hear it because I have a headset on, but they made a little noise, and then you could smell burning. Or I could smell burning. I don't know if you guys smell burning, but I could smell it. And let me pull back up this other one. Thank you, Ollie. It is a struggle at times. It also is very useful at times when it comes to like resistors and stuff. But I was struggling earlier with that capacitor because I dropped it on the desk and I couldn't pick it up, which is why your girl got tweezers. But I just blew this up. Make sure it's not too hot. Okay. I'm gonna have to use a different LED now because I burnt this one. It's kind of hard to see. I don't know if I can get it. And see if I can get it up close. Yeah, you're not really gonna be able to see it in here just because of the camera quality. But just vaguely in the middle, there's like a little black line. Because the filament just burnt. And the reason the filament just burnt is because I set the circuit up backwards. And I looked at it and I had a feeling, and then I did it anyway. But what happened was I set up, I'm gonna do it again, but I'm gonna do it the right way. I had it set up where the power was flowing in, and then it went through the LED, then through the resistor, then to ground. Really, you should have went into from power to the resistor to the LED and then to ground. And because of that, this LED got a straight 5 volts of power, which is too much for it to handle, and therefore it fizzled out and burnt. Now, what the repercussions would have been had I left it plugged in, I don't know, because I don't want to test that. So instead, I'm just going to rebuild this real quick just to make sure it works. And then I'm going to, if this works fully, I'm going to put the circuit back on here. And then in order for us to get power and ground, I'm going to use this 9 volts. Let me pull this back. I'm going to use this 9-volt battery. I said we don't have an adapter for this either. So instead, I'm going to cut the wire, strip it just a little, roll it up, and then I'm going to solder it. I'm going to solder the ends just a little. I was checking if my soldering iron was on. But yeah, so I'm going to do this real quick. And try again. There's like FM, which is, I know sometimes I use real words. FM is just foreign material. It's very important to be aware of. Not as much for what we're doing, but basically, if you're working on like very small circuits and components, very advanced circuitry, even the smallest little for material, dust, dirt, whatever the case may be, can completely ruin everything. I say this as a person who works in a company where you have to be in a clean room and wear bunny suits and hairnets because they don't want you to get FM everywhere. Okay, I'm gonna switch out this resistor because I think this one is too low. Do a quick fix real quick, and then hopefully we can get this working. And if we can get it verified that it works, depending on time, we'll either go ahead and start soldering, or we will do that next week. Either way, we'll be done by next week with this. So that gives about a week, 2 weeks for everyone to kind of look over what I have in the what I'm gonna put out there for the polls for which robot we want to work on next. Originally, I was gonna build an obstacle avoidance robot from scratch, and then I decided not to, just because I have so many other robots around me that are not built or need work. I'm like, you know what? It's whatever. We're just gonna focus on doing these ones, and then depending on how the show goes and time frames, we can work on building one completely from scratch. So I'm gonna try this again. Kind of hesitant, but we're about to see. Let me scoot it into frame. Too many things in my desk. Don't mind me. Okay. So let me put a different color. I realized white is probably the worst color in this case. Do blue one. Might blow out another. I'm so concerned now that, like, even though it didn't explode or anything, now I'm all like, oh my god, I'm gonna blow up another LED. Which if I do is fine. Like LEDs are like cheap as super cheap. So if I blow up 20 of them, I'll be fine. I'm trying not to blow up 20 of them. I'm just gonna go ahead and plug in the circuit again. And let's no. We're being stubborn today, I see. Alright, give it one more shot, and if it doesn't work, I don't want to spend too much time on it, because I know it does. I know the program is on that circuit just because of the fact it came on before and burnt it. So we'll see. If this doesn't work, we're just going to keep going and see if I can get this other circuit on. As I said, today is a debugging type day. This is just always how it is. And I said, once we find out that it works, moving it to the breadboard, which we're going to do it on this breadboard, because I realized the other one that I have is just not going to, the pre-built, laid out one like this isn't going to work. These channels in the middle for the circuit would work originally, but it's not, doesn't have enough for the circuit we're using. So I'm just going to use this one, which will be a bit better for like learning purposes anyway. But once we get to that point, it shouldn't be too bad or take too long to transfer all the pieces over. It's just a matter of doing it. Simple mistakes. That's probably partially why it blew up too. So you notice at first that it did come on, it stayed on blue. And then I was like, why is it not turning off? It's almost like it's getting power and not reading from the program. And then it looks, and I realized it was plugged up to power and not to the pin, to pin 13. So technically, yes, it was connected, but because we programmed pin 13 to do all the work, it wasn't plugged in there. So it's like, I don't know what you're talking about. So now we know it works. So we have to circuit the code on our integrated circuit. So I'm going to stop this. I'm going to move it back. Sorry, I keep doing. There's cables everywhere. Wire management is so important, and I need to probably prioritize it eventually. But not today. So we're gonna do. All right, let me move this. All right, so I'm gonna take this back out of here and put it back onto our circuit. And we're done with this for now. Then get this and put it back on here. Swoosh. And I believe should go right there. All right. It's crunch time. I'm stressed. Whenever it comes to testing a circuit, I'm like thinking of every literal thing that could go wrong. I'm like, what if this is backwards or this? We're gonna find out what's gonna happen and have our fingers crossed that it's gonna work. But our first step, before we get here, we want to make sure we have our power set up. To remove this, we're gonna solder for a minute. So, step one, scoot over this way. There we go. All right, so we have this. We said we're going to use this 9 volts for our power. And then we already have our 5-volt regulator set up. So we should be good on not getting a full 9 volts of power when the time comes. I realize I'll fix that in a second. So what we're going to do is I'm going to go ahead, took the battery off, of course, because we don't want to play with active voltage. That's just asking for trouble. I'm going to cut this. As much as I hate cutting wires and it like gives me anxiety, I'm going to do it. Just gonna do that. I don't have actual wire strippers, which I realized a few days ago, and then I just didn't get them. So we're going to do this very carefully. And I'm just going to very carefully try to get off some of the excess for the heatsink. It is not the preferred method. I don't recommend doing it this way, but that's what we're gonna do. So I just ripped off. See if I can get it on here. Yeah, I can't really get it to zoom, but you can tell that like it's ripped off, and it has just a bunch of little wires in here instead of just one. So what I'm gonna do first is just spin it so they're all around each other. Step one. This is something I think I said I was going to go over like when we first learned how to solder, and then I didn't because we ran out of time. But it's very important for if you're connecting wires. Even say, what's an example? I know people don't really use wired headphones anymore. I say as I'm wearing a wired headset. But I'm sure we've all experienced moments where we've had headphones and like one side goes out. This is usually why it's like stripped or too pulled on the inside, and this is how you would fix it. Usually, is you would get the wire. Usually, use actual strippers. Get the outside off. I'm trying to do it without cutting through, which is a struggle. That's why I usually use wire cutters or strippers. And have to adjust. All right, I think that's good. Yeah. All right, do the same here. So this is what you would do if you had like headphones. You would strip it off. You would probably cut it back a bit because the problem is more likely close to the base. Like it would be closer down here, like where you plug it in to your headphone jack. So you cut probably a little bit of it off. And then you would get it, connect it off into one. And then from here you could technically plug it straight in as is with the little wires. But for more conductibility, as well as it's very loose, it's not very stiff. Well, it's a little stiff. But just so it doesn't unravel, we're going to add a little solder to the end. So pull out these bad boys. I don't know if I'm going to get it all the way in the zoomed frame, but we're going to see. We're just going to do what we do. Whatever happens, happens. Put them both in there. You get a little bit. Alright. Don't mind my tape. There's reasons for this tape, which hopefully I'm sure are very obvious. Yeah, let me see real quick if I can do a thing. Make this just a little bigger for you guys. Digging into it. Yeah, we'll leave it there for the moment. If it's not clear enough, I might move it to another position. Because I now got empty space. But I'm going to get my same solder I used last time. Unroll it a little bit. Lay out. And got the soldering iron here. Right now it's set to 375 degrees. So let me goggle up real quick so I don't burn my. I have glasses on. Usually it's like, usually if you have glasses on, they still recommend you having either attachments or the goggles on top. Sometimes I don't care, to be honest, but if I know I'm going to be doing stuff like this, then I will try to have them on. So as we mentioned before, make sure you dab it a little bit, get off any excess. Then we're going to tin it, like I mentioned before, which is just putting a little bit of solder on. Let's see if I can get it in. Oh, just going to put a little solder on the tip. And it adds like a coating to protect the tip. And it also makes the heat transfer easier. And then I'm just going to add a little bit of solder onto the wires. Scoot it back down. Add just a little bit of solder to the wires on the ends. It's almost like painting. That's what it feels like to me. I think I added enough that I'm like, all right, I want to even it out. So I'm just like trying to smooth it down a little bit. And then the same here. This is not smoothing out, which has agitated me. And it's because the wires aren't fully twisted on this one. Alright. So let me take these off and look at it real quick. I'm gonna trim the end. Let me see. It's not really gonna be that visible because of gray wire on top of a gray desk. But you can kind of see a little bit on the red. Will this help? You can see a little bit of it on this red wire where it kind of joints, collects up at the end. Black wire, not as much. It's a little smoother, but it's hard to see, but there's some loose wire at the end. So I'm just going to trim it off. From there, we should be set. Move this out the way. Yeah. I think these back offs are annoying. So then, probably won't solder today, so I'll turn it off. I don't think we'll have time. But if this works, we'll just go straight into soldering next week and we'll be all done with this project. So I'm gonna leave these wires hanging. I'm gonna plug this into. I want to put this back. Really, doesn't matter as long as it's on the red or blue line, because of the fact that we have at the bottom here these jumper connections. So whether I plug it here, 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 whatever, it's still gonna go up this whole loop. And then if I put it on this side, these jumpers will also transfer to this side, vice versa. So it really doesn't matter where I put it. But I'm gonna put it over here. So I like to have it in the top corners, so it's out of the way. Plug in ground. I'm concerned that ground is not making a full connection. I think I snipped it. Let me figure this super fast. Hopefully we can get at least one full test run up. Yeah, to connect all the way. So I'm gonna try to fix this super fast before my iron cools down. So I literally just cut it off. I'm gonna do it. Super quick. If it'll rotate. Any more questions in the chat, comments, concerns, suggestions? Have you worked with doing this before? Let me know. Tips and tricks if you have. Melt. There we go. It'll do. All right. My fan's on, or my window's open. It takes like 2 seconds to dry. All right, let's try this again. I was like, why is it not struggling to go in there? It's like, oh, because every wire's not connected. That's why. Cool. So got ground. I'm just going to connect the battery, not plug in power yet, just because I'm nervous. And we're going to see what happens, if anything happens. Actually, before I do that, I'm going to do one more thing. One last test before I plug it all the way in. I'm so nervous. I'm going to plug it in over here. Flip it. I'm going to plug it down here first. On that circuit we just tested. Of course, it's not going to blink because it's not connected to like actual circuitry. But I just want to see the check again if my battery works set up like this where I have it cut. So it should turn on and just stay on if the power and ground are still good with the way that I soldered them. Go. Okay. I feel like I'm about to blow this one again too, just because this is 9 volts of power, and this resistor, I think, is meant to handle 5. Okay, cool. We're good. Oh, I don't know what that was. I took it all the way off and it still blinked for a sec. I was like, oh, this was a capacitor that made sense. Like this right here. If I had a capacitor here and did that and put it through, then when I unplugged power, it would stay on for a little bit. Because like I said, the capacitor is almost like a battery where you can fill it up with charge, it'll hold the charge, and then even if batteries or power's not there, it'll just start draining from the capacitor. Maybe we'll try that out a different time, but for now, we know that our battery works when wires are connected. So let's see. Let's see. I'm concerned very much. I believe off the top of my head, I believe that when we turn this on, I believe this LED should come on, appear. Pretty sure this is our power LED. So this should always come on as long as the circuit, quote unquote, is getting power. So that should be our test just to see if we're getting power. Forget what this one does. This is, I think, the blink LED. So this is for testing like the blink function. And if it's set up to 13, like I think it is, then that's the one we'll test as well. We're gonna see. I'm gonna pull up the pin map real quick, just so we can double check. Okay, so we're looking, we have it set up for 1, 2, 3, 4 from the bottom. So looking at our pin map, 4 from the bottom is digital pin 12. So yeah, that should be the blink for something else. Yeah. We're just gonna plug this up and see what happens. Whatever. And then if it works, great. If it doesn't work, we will edit it later. I might edit it off camera so that we're not here all day next week debugging this. That way next week, regardless, we can go ahead and hop into moving it onto the breadboard and having a fully finished product. We can do like questions or whatever from there. All right, so the final test. I know I'm stalling because I feel like it's gonna break, and it's concerning me. Because I'm looking at some stuff, and I'm like, I don't know if you're in the right orientation, and it's mildly concerning. Yeah, like this LED down here is going through. I'm just gonna take it off. Actually, let me just take this off. Because looking at the way that one's set up, I'm pretty sure. Oh, you can't see it. My bad, guys. My bad. My bad. Let me move this back over here. All right. I took off the LED that was right here, way down here, way down there, because the way it was set up, it was going to take power from the board into the pin, then through into the LED, then through the resistor, then out, which is the way we just had it set up, what made it burn out. So to avoid that potential problem, before I recheck out some other schematic stuff, I'm just going to take it off. I'm going to put on my goggles for this because something I'm just concerned. Just like software, it is a miracle if it works the first time. I have low hopes, honestly, that this is going to work immediately. However, we're going to try it. If it doesn't work, like I said, I'll work on it off camera and get it working. If it does work the first time, great. The only difference between software breaking the first time and hardware is if hardware breaks, then I have to find which unit in here broke and replace it. And if it's bad enough, all of it will need to be replaced, which isn't horrible. I have backups for everything except the circuit, but let's see. We are going to see. You're already stressing me out. In 3 seconds. Nothing. Well, that's better than an explosion, but so I just plugged this into power. Nothing happened. The 9 volts should be plenty enough. Not tripping. No, I'm not tripping. I'm gonna try to plug this back in and see. Because at the very least, what should happen is this LED, this green one should come on. Because it's not tied to like any of the other circuitry going on. Yeah. It's not tied to anything else. So at the very least, that one should come on. So we're gonna try one more again. Just gonna plug it in. Nope. So stingy. And then I'm just heat checking everything. That's why I keep touching it. Because if there is current and stuff isn't coming on, that means it stopped somewhere. And if it stops somewhere, it's going to generate heat. But nothing's generating heat. Which makes me think something else is going on. Nope, we're fine. Alright. That was backwards. Oh, let me just check something. So technically we have power. That's good. Let me hit this reset, see if anything will happen here. Yes, something is happening. I think it's getting too much voltage. But technically this reset button is functioning because when I click it, I can see it trying to interrupt, but not much. Alright, and then what I'm going to do for my last test is I'm going to connect that LED back. Let me unplug this before I start ripping stuff up. Alright, so we'll do this last test and we'll probably wrap up for today. So we have this connected to this pin. 1, 2, 3, 4. Once again, I believe that is 12. So I'm going to connect the LED that I just took off back to pin 12. And I'm going to change the code to say 12 instead of 13 just because 13 has some stuff going on from the looks of it, which might also not be right. But I'm going to connect it to 12. Wait, I can't have to connect 13. Yeah. We'll do a quick adjustment. Should be done in just a moment. And what I'm doing right now is just checking where I put some of these lines in comparison to what is showing on this pin map right now. Because according to this, some of these are in the wrong spot. So they should all be shifted up just one position. If I can get them to do that. Let me make sure of our comments. All good. While I'm fixing this, definitely drop some stuff in the chat. Let me know what you think about what's going on, what we're building. If you think you could rebuild it, if I put out like a tutorial or some sort of article or something about how to build this, do you think that you would be able to? Or have you done this before? I know it looks like a lot, which it is, to be honest. But really, it's just a practice thing. And honestly, it probably looks more like a lot just because I'm doing like a lot of edits on it. But if I were to put out like a tutorial about this, it would be 5. It would be without the issues, of course. It would just be like, this is the right way to do it after I've gotten it working. So I'm gonna go and I'm gonna use this same. Well, since I have this set up at the bottom, I'm gonna use the same one. So I'm just gonna connect it here. The reason, let me scoot it up. I can get it all the way in frame. So down here, I'm using this white jumper. So now I have pin 13. And the only reason I left it, I had to move it to 13 was because I already have the program here to 13. I don't take it off, move it back, tell their board to program it. Move it down here. Then we have this white. We're going to move this white cable and connect it to this LED. And then out and to ground. So in theory, if I plug this up, not only should this LED come on, but this one should come on as well and blink according to our program. If that's the case, we have a completed, fully functioning microcontroller. It's not pretty, but it works. If it doesn't work down here, and there's some other stuff I gotta figure out. So we'll see what's about to happen. Regardless, I don't know. Oh, snap, almost cursed. I'm so happy it didn't blow up. Alright, so you can see up top, we have our green light is on, right? But you see down here, our blue light is flashing too. Which means it works. It's fully functional. So now we can really do whatever we want. It's at a fully functioning position as if we had just our raw microcontroller that I've thrown somewhere and don't know where it is. This one. It is at the same level of functionality, except for the 3.3 volts, as this. This is what we have created here. It works. Now the pins is a little more complex because the spacing, like the way we have this set up, we had to plug it in, like, you know, wire everything all the way down. Take this off. I had to wire everything from this exact pin down here all the way to get it to work. Say I needed to use like a different pin. Yes, I have certain spaces along the side. I have a bit more spacing along the sides of this, but it's still really cramped. And it's not neat if you're showing this to someone else. It's like, yeah, it works, but like I can't really explain what's happening. So that's why we then go and we move it to a board like this. And then that way, instead of having the pins just kind of be plugged up here, we can add headers along the sides and we can just plug in directly. So I don't know where my headers are to show you guys. These guys, I think. Yeah, so we'll add these real quick. Something like this to the side. And that's basically what's on the Arduino. So we'd put it on and snap a piece off. Actually, I can't. These don't snap. I gotta cut them. So say I had a little piece like this, right? I'd have all my circuitry here, all my circuitry like here along the middle, and then I can have this here on the side and put it on either side and then run lines underneath it, because of course the underneath is going to look a hot mess. The underneath is going to look like this, but worse. But the top we want to look clean. So I can have this set up underneath, connecting all these type of wires at the bottom and run it to these lines, and then that way I could just be like, oh, I need pin 13, and then just like buy out like that. So that's what we're gonna do next week. Now that we have this working, I'm very excited because this works, and I really was not expecting it to. I'm glad I caught a couple things as we went in terms of like this being backwards, this LED up top, these wires being in the wrong place. I am gonna have to go through this and more time to just verify some other things. Um, but otherwise, we have a working microcontroller that we made from scratch. So you can always do something like this, and then the upside to make them from scratch is you can edit it. You know, you can add like a 6-volt power source on here, or you can change to a different crystal. You can change a different integrated circuit if you wanted to. But this is basically done. We did it. I'm so excited. Not showing it, but I'm excited. So that being said, I'm gonna start wrapping us up. Let me go back to me. So yeah, it's exciting. I'm gonna put out some info about it a little later. So stay tuned on that. And like I said, between now and definitely between the next show, because the next show, of course, we're definitely gonna just transfer this to the proto board and have it just look nice and neat. And who knows, if we get it working fully right on the proto board, which shouldn't be too hard because it's just transferring everything piece by piece. We might just use that going forward if we decide to use Arduino or microcontrollers. I said the next 2 robots will be Raspberry Pis, but after that, if we decide like, yes, let's make a obstacle avoidance robot or a drone or something else using an Arduino, we can make our own or use the one that we built. So something to keep in mind. As I will put out the poll probably on my Instagram as well as Discord, because I'll probably stay on Discord longer than on my Instagram. And I'll see what you guys are interested in. Are you more interested in seeing the hexapod getting built / programmed and seeing it walk around and do crazy stuff? Or are you more interested in seeing that smart car get fully functional working? So after we finish this, the week after next, we're going to be working on one of those robots. Whichever one shows a little bit more interest. By then I should have everything set up for the Raspberry Pi. Hopefully we can get started on some more. It won't be as advanced hardware wise, just because they're modular. A lot of them, for example, let me show you real quick. By modular, I mean I don't have to build the circuit from scratch. I don't have all these wires to have to do from scratch. Everything's just plug and play for the most part on these types. So hardware wise isn't that hard other than the structure. But coding it will be the hard part. So when we work on these robots, a lot of it will be more code heavy, pulling in data, interacting with things that way. So I just want to thank you all again for coming to the show, watching this microcontroller unfold and build. It was very exciting. Very excited. I haven't built one from scratch in like 5 years, so I was like, please work. So I'm glad that it works. Glad you all are here. Definitely between now and then, reach out to me about questions or things that you're interested in seeing, suggestions for the show, etc. Make sure to follow us here on our Twitch so you can get updates about when we're having shows. My show is always going to be Saturdays at 2 p.m. Eastern, or 2 p.m. Standard Mountain California time. Which time zone is that? Pacific. 2 p.m. Pacific and 5 p.m. Eastern. There's so many time zones in America, I just lose track. Same time, same place. Make sure to follow us. You can do that. Make sure to join the Discord so you can interact with everyone in our community, and come back in about 50 minutes for Brian so you can see his tech topical show and learn more about current and advancing technologies. So with that being said, go ahead and thank you all for joining me again, and I will see you next week. Bye.